Hey kids, Mr. Murray here, Mr. Murray's Mathland. Today we are solving quadratic equations of the form x squared plus bx plus c equals 0, and we're doing it by factoring. And a quadratic, remember, means an equation where the highest exponent is 2. So we're talking about trinomials that are quadratics today. Okay, so example 1, we're going to get right into this here. Solving this equation, x squared minus 13x plus 12 equals 0. Remember our three-step process here for solving equations that are not linear, that have higher exponents than 1. Step 1, make sure it's equal to 0. And this equation already is equal to 0. Everything is on one side, so we're good there. Step 2, you want to factor it, express it in factored form. Factors are things that are multiplied. This is not in factored form, so this is what we've been working on lately, is how to factor a trinomial of this form. So it's a trinomial, and it starts with just 1x squared. So this should be an easy unfoil. Make our two sets of parentheses for our two binomials, and because it's just 1x squared, I know it has to be x and x. And now I'm looking for two numbers that multiply to be 12, the constant term on the end, that's positive 12. And those same two numbers have to add up to be negative 13. Okay, so two numbers that multiply to be positive, they have to have the same sign. And since they're adding up to be negative 13, that means they must both be negative. So what multiplies to positive 12 and adds up to negative 13? Well, you probably don't have to think too hard. 1 times 12 gives you 12 and adds up to 13. So make them both negative. Doesn't matter the order. They're both negative. So those are the two numbers that we're looking for to complete our factoring. So x minus 12 and x minus 1. You can check that by a quick FOIL if you were not sure. And then step 3 of the solving process is set each factor equal to 0 and solve. Remember, that is our zero product property, that if we have two things multiplied and equaling 0, then either this equals 0 or this equals 0, or both equal 0. So this is where we split it, where the multiplication occurs. And x minus 12, this factor, either equals 0, or this factor, x minus 1, equals 0. Pretty easy equation to solve. Just add 12, so we get x equals 12. Add 1 here, and x equals 1. Two solutions. Quadratics are always going to have two solutions. That's something you're going to learn in algebra. Whatever that degree is, whatever that highest exponent is, that's how many solutions the equation is going to have. So kind of a nice trick to know. So 12 and 1, you could check by plugging them into the original and making sure it equals 0 if you like. Okay, second example here, just to see a couple more here. X squared plus 3x equals 40. Step 1, make sure it equals 0. So this does not equal 0, so we want to bring everything to one side, and this could easily be accomplished by subtracting 40 from each side. Let's move that to the left. And now our new equation will say x squared plus 3x minus 40. And remember, you want to write it in that standard form, with x squared, then x, then the constant. And now we've got it there equal to 0. Now we want to try to factor it. It's a trinomial. Starts with x squared, so I know it's x and x. Just got to think of those two numbers. What are those two numbers that have to multiply to be the constant of negative 40, and those same two numbers have to add up to be that positive 3 that's in the middle? What two numbers will do that? You run through your list. You know that one has to be positive and one has to be negative because it's multiplying to be negative 40. And 8 and negative 5 are the two that we're looking for. That multiplies to be negative 40, and 8 plus negative 5 will add up to positive 3. So in our factoring, it's positive 8, so x plus 8 would be one of the factors, and negative 5 is the other one, so x minus 5 is the other factor. So we have now factored it, and now we're going to use our zero product property. If x plus 8 times x minus 5 equals 0, then either x plus 8 equals 0 or x minus 5 equals 0. And that's going to give us this opposite relationship that we always get with these factors. So either x equals negative 8 or x equals positive 5. Very cool, right? And one more example here. Hopefully you're feeling pretty good about these if you've been putting in the time with your factoring. And this is not so hard, just going one step beyond that. You just gotta watch all the little things in the middle. So this one again is not equal to 0, so I'm definitely going to bring it all to one side. And you notice that I've got all kinds of terms here on both sides. One thing is, when we factor these, we usually like our x squared, the leading term, we usually like that to be positive so that we can go x and x, right? So when I have quadratic terms on both sides, 2x squared, x squared, I'm going to bring it to the side where there are more x squareds. So I've got 2x squared here and 1x squared here. I'm going to subtract x squared. I'm going to bring everything to the right side here, because that way, when I combine my x squareds, I'll have 2 minus 1. It'll be positive x squared. So I'm going to bring everything to the right side, which means I'm going to subtract 6x, bring this all to the right. I'm going to add 5. Okay, so our new equation is 0 equals 2x squared minus x squared is x squared. Negative 3x minus 6x is negative 9x. And negative 41 plus 5 is negative 36. Okay, if you did bring everything to the left, you would have the same exact equation, except you would have, you'd have negative x squared plus 9x plus 36 equals 0. You would have had the same equation, except every sign was opposite. And then at that point, you could divide everything by negative 1 to make your x squared be positive, which is just factoring out negative 1. So it's not a big deal if you don't do this, but as a nice rule, maybe you think ahead. Let's try to keep the x squared term the positive one. And now we're ready to go here. We want to do our unfoiling pattern here, our trinomial. It's just x squared, so x and x can go there. And now two numbers that multiply to be negative 36, and the same two numbers have to add up to be negative 9. We know they got to have different signs to multiply to be a negative. You run through your combinations. If you have to make a little list of all the factors, by all means do so. The bigger number is going to be the negative 1, since it's adding up to be negative 9. So this is going to be negative 12 and positive 3. That will multiply to give you negative 36, and negative 12 plus 3 is negative 9. So your two numbers are negative 12, positive 3, and now zero product property, set each factor equal to 0. So x minus 12 equals 0, x plus 3 equals 0. You might start to kind of skip this step because you start to notice that, hey, I can do that part in my head. I'm just adding 12, taking the opposite of the number that's there. And, just do so at your own risk, of course. And solving this equation on the right means x equals negative 3, right? Just subtracting 3 from both sides. And there we go. There are our two solutions. So 3 different examples, each one, slightly more work to get it into that standard form before you factor, but shouldn't be too bad. But if you need to see more examples or you need more help, just ask.